Okay, today we are going to talk about finding limits numerically and graphically.
Do you make it full screen?
Oh, yeah.
Yeah. Thanks.
So, first of all, we need to know what a limit is, okay? So, a limit, the mathematical definition is a limit as x goes to a of some function f of x equals L. The way you say this is the limit of f of x as x approaches a is or equals, either one is fine, L. So the limit, you read the limit here, of f of x, so of this function, as x approaches a, and that's the x, and this little thing is an arrow to say approaches, because it's going towards a, yes, equals L. Okay, so the way that I find the easiest way to explain this is a limit is where you are going to, not necessarily where you're at. So, what I mean is, let's say you're going to the mall but you take a detour, you're still going to the mall. So the limit would be like the mall, okay? Graphically, the reason why I say where we're going to is because let's say you have a graph like this, okay? Let's say that this here is A, so we're saying as x approaches A. The limit here is the y value L, because this is a continuous graph. By continuous, we mean that it goes on and on and on forever. I want to finish explaining this. As x gets close to a, where is the point? So this value is going to be a y value, okay? So the y value here is the y value that's on the graph because it's filled in. Let's say that we have a different graph. I'm going to make it similar but a little bit different. So I'm going to start here, go down and come back up. And I'm still going to have my point A, but now let's say I have a hole in my graph here.
Why is there a hole?
Okay, because some functions have holes in their graph, okay? So, even though there is a hole in the graph at A, so even though the graph doesn't have a y value at A, we are talking about the y value that it is getting closer and closer and closer to. So, that would be this y value, L. So your answer is still L, which is the y value here. If you take the same thing, let's say there's another hole in the graph here, but the graph is filled in down here.
What? Why is there that dot there?
Because sometimes you have graphs that are filled in at a different point, like they're piecewise functions. They're filled in at a point here, but they're open here. You're talking about the limit is where this is approaching. So in all of these cases, the limit as x goes to a of the graph is L. Here, f of x equals L. And here, f of x is undefined because there's a hole there, and there's nowhere else that it is. Here, that point is f of x. So it's not necessarily where it's equal to, it is where you're going. That was my point. You want to know where you're going. You're getting closer and closer here. Here, it's like, oh, we went to the mall, but we took a detour. Like I told you guys, it's not where you take a detour, it's where you are going. So graphically, that's what it looks like.